Okay, one of the things, sure, third period wants to say hi, folks. There we go. Okay, one of the things that, all right. One of the things that I wanted to go over with you briefly is I've mentioned if they're unit circle values, that anytime you're asked to do, say for instance, inverse sine or arc sine of 1/2. We know that 1/2 is a unit circle value, so that's just basically working backwards and figuring out where on the unit circle does that happen. Okay, so how do you know whether they're unit circle values or not? Is something I've been asked before, so let me just talk about that briefly. Basically, we know these numbers are on the unit circle, so pretty much we're talking about 0, 1, 1/2, square root of 3 over 2, square root of 2 over 2. If we see those numbers are from the unit circle, or the negatives of them. But another thing that would be a unit circle value, because sine and cosine, well, because secant is the reciprocal of sine, and, secant is the reciprocal of cosine, and cosecant is the reciprocal of sine, and cotangent is reciprocal of tangent. We also have the reciprocals of these, so let's think about those. Reciprocal of this would be undefined, so that's a unit circle value. Reciprocal of 1 is 1. Reciprocal of 1/2 is 2. Reciprocal of square root of 3 over 2 is 2 root 3 over 3. Reciprocal of square root of 2 over 2, this means the exact same thing as this. This is where this came from. This is 1 over the square root of 2. It's just rationalized. So if we turn it over, it's just plain square root of 2 over 1. Okay, so those are unit circle values. In addition to that, there's also, and this is on the other video I made, talking about the tangents, thinking about what the tangents would be. So tangent, remember, is sine over cosine. So for instance, if I'm doing 1 over 0, the tangent here is undefined. If I do square root of 3 over 2 over 1/2, remember that if you have the same denominator when you're dividing fractions, that's going to cancel out. If you want to see it in action, this is what happens. So we cross cancel that, and that's why it cancels out. But once you know what's going to happen, you can just get rid of it. And so this is square root of 3 over 1, which is just square root of 3. So the tangent of pi over 3 is just square root of 3. The tangent of pi over 4, and all the points that go with pi over 4, is just 1, because you have the same coordinate for both the x and the y. So anytime you put something over itself, you get 1. So it would be negative 1 down here, but it's still going to be a 1. And then this one is probably the most complicated one out of the tangents, is 1/2 over square root of 3 over 2. And again, you have the same denominator, so those would cancel. So it's this, but it has to be rationalized. So this is what the tangent is. Square root of 3 over 3 is what the tangent is here, or all the other points that have those same coordinates, just in a different sign. And if you have 0 over 1, that's 0. So the ones in Sharpie here, these are tangent values, and everything in the other quadrants, you're just going to have different signs with the same values. So undefined, square root of 3, 1, square root of 3 over 3, and 0. So those are also numbers that we can kind of consider unit circle values. So undefined, we already talked about that. 1's already on here as well. Square root of 3, and square root of 3 over 3. So basically, if you see in this spot any of these numbers, then you need to be thinking about the unit circle and thinking about where that could be on the unit circle. When I say if it's a unit circle value, then you just use it and do it from the unit circle. There are cases when it's not a unit circle value, okay? And I'm going to make you a little video on that in just a second. But that would be something like this. If I have inverse sine of 4 over 5. 4/5 is not any of these numbers. 4/5 doesn't come from the unit circle. So I would have to do that a different way, which is to draw a right triangle. So I just wanted to make a point of, what are unit circle values when we talk about that.